We are talking about lines today, and these are your regular old y equals mx plus b lines from high school. So a lot of this should look familiar, mx plus b. And with those m's and b's, your line might look like y equals 2x plus 3. Okay. M and b are numbers in those lines. And when a mathematician says a line, they're referring to something completely straight, like maybe that, or a nice vertical line. Not something like this. We will get to curves like that, but we call that a curve, not a line. All right, but this video is just going to focus on the slope, which is the number that is in the place of the m. So in our example, that would be the 2. That is our slope, and it has to do with how steep a line is. So let's hop over to Desmos and talk about slope. All right, so we're going to talk about steepness today. So we can recognize, looking at these pictures of these two rides, that the difference between these two rides is not necessarily how high up you are, but how steep these rides are. So I'm going to zoom in on this gondola here, and I'm going to turn on a line. You might remember from high school that slope is rise over run. So I'm going to turn on the rise and the run of this line. Okay, so from one point to the next, how far do you have to run, meaning horizontal, and how far do you have to rise, meaning up or down, to get to the next point on the line. And I'm going to try to drag this on top of the gondola line. And let me turn on the grid here so we can see this. Okay, so I'm going to drag this point down here so it looks like it's going through that gondola spot. And then I'm going to put this, all right. Okay, so it's really hard to see how far that rise is. It's a negative number because it's rising down. So this is saying that if you're going to go 1x tick mark, you're only going to go down 0.16 of a y tick mark on this ride. Okay, and our slope, let me turn that calculation on. Rise over run, because I made that x tick mark a 1, the slope is just equal to the drop in the y coordinate. Okay, so let's compare this to the slope of the roller coaster ride. Okay, so let's see. And I'm not going to, obviously this is not a straight line ride, but I'm going to try to match just the steepest part of that ride that I can. All right, and that looks pretty close, measuring the steepest descent of that ride. Okay, so I kept my X tick mark at 1, so my run is at 1, and you can see that the Y drop for just one X tick mark is negative 4.36. And you can see that's a much bigger number, all right? So this calculation, rise over run for slope, is a numerical way of measuring the steepness of a line or of a ride. Okay, so now we're comfortable with rise over run telling us about the steepness of a line, and I want to come up with a formula for it that we can calculate slope without relying on Desmos. Okay, so I've got a line with 2 points, and I'm going to give them some pretty mathy looking coordinates here, x1, y1, and x2, y2. All right, and the subscripts just let you know that these 2 points belong together in a pair, and these 2 points match together in a pair. And again, those coordinates just mean that this tick mark, whatever that number x1 is, goes there. This tick mark would be x2, and then I'd have y1 and y2. All right, so what Desmos was doing for us was calculating this rise and run. Okay, so it was calculating the rise and calculating the run. This one was my rise. This was my run. All right, so how was Desmos making those calculations? Well, for the rise, all it's doing is treating the y-axis like a ruler and just subtracting those two y-coordinates. What's the difference between those two tick marks? Okay, so the bigger one minus the smaller one, y2 minus y1. And the same thing on the x-axis for run is just using the x-axis as a ruler. It's going to subtract the bigger one minus the smaller one, x2 minus x1. All right, so our slope that is rise over run is just going to be the difference in the y coordinates over the difference in the x coordinates. So our slope formula over here is going to be y2 minus y1, that's our rise, over our run, x2 minus x1. All right, so let's go try this out with an actual example. Okay, so I copied our two notions of slope here, rise over run, and the formula we just came up with, and now we want to calculate the slope that actually passes through these 2 points. Okay, so it doesn't really matter which one you label as x1, y1, and x2, y2. Just don't mix and match your subscripts. Make sure they're in the pair together. Okay, so I'm just going to plug into my slope formula, y2 minus y1 on top. So that's going to be 2 minus a negative 1, subtracting y coordinates. And then on the bottom, we subtract x coordinates, 9 minus a negative 3. And just do a little arithmetic, right? Both of those are going to, negative negative makes 2 plus 1. And 9 minus 3 makes 9 plus, 9 minus a negative 3 makes 9 plus 3, which is 12. And we can reduce that, right? Those are both divisible by 3. So let's divide by 3. And I get my slope is 1/4. Okay, so let's just plot those 2 points in that line and think about what a 1/4 slope means. Okay, so I'm going to do a very rough sketch here. So we're going to have negative 1, 2, 3, comma negative 1. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way out here, comma 1, 2. And let's connect that with a line. Okay, so there's our line, and that slope means that rise over run, for every 1 tick mark that I go up, I'm going to have to go 4 to the right. Okay, so I would have to go up 1 tick mark and then 4 to the right. Up 1, 4 to the right. Up 1, 4 to the right. That means that my line rises from left to right. If instead I start over on the right and I travel to the left, if I did that, I'd be going down and to the left, down and to the left, down and to the left. Okay, so that would be like a rise over run, a negative rise going down, and then a negative 4 would be going to the left. Okay, so still, even when I think of it in that blue way, negative 1 over negative 4 would still give me a positive 1/4 slope. Okay, so as long as the rise and the run match each other in sign, positive, positive, negative, negative, that means you're going to have a line that's rising from left to right. Okay, so positive is one of 4 things that can happen when you calculate slope. If your slope is positive, you're going to have a line that is rising from left to right. If your slope ends up being negative, that means that your rise over run was either negative over positive, or it was positive over negative, that the 2 signs didn't match. Okay, so that means that you are either going down and to the right, or you're going up and to the left to stay on your line. Either way, your line is falling from left to right. Okay, so negative slopes give you lines that fall left to right. A line with 0 slope, okay, that's going to be a line that is horizontal. And think about why. Your rise over run, there is no rise to that line. That line is all run. Okay, 0 over whatever run is going to give you 0. And then the opposite thing happens with undefined. That kind of sounds like a weird thing to be undefined. Okay, but think about a vertical line. That line is all rise and no run. Okay, remember that you cannot divide by 0. That is undefined, that doesn't exist. So you could say that the slope is undefined, or you could say that it does not exist. And we say the phrase so often, does not exist, in calculus that we use this abbreviation frequently, DNE, for does not exist. All right, so in the next video, we're going to talk about how to find equations that represent all these different kinds of lines.